Hey everybody, welcome back to the shop. I'm about to begin my next viewer project here. What we have is a couple of pulleys off of a 14-inch South Bend drill press. These belong to one of our longtime viewers named Chris. He resides up in the Waterford, New York area, and he says that this is a project he's been working on restoring. And he had an incident where he accidentally chipped the pulleys and they needed to be welded up and remachined. He reached out to me and asked would this be a project that I'd be willing to help him with. I said, yep, send him on down. So we'll start with this guy here. I love how it's got the the South Bend letters cast into the pulley. Pretty cool. And you can see our weld buildup right there. I do have a couple of photos we'll throw up there so you can see what it looked like as he had sent it, but it was just chipped out. And all we did was just TIG welded up, and we're going to set this up in the lathe and just turn it back smooth again. All right, same thing with this guy right here. This one had a little bit larger chip in it, and I took these over to my buddy next door, Joe. He owed me a favor, and I asked him would he mind welding these up for me, and he just took care of it for me, and I'll go ahead and take care of the machine work. So what I'm planning on doing with this guy right here is that I'm going to go ahead and use one of my expanding mandrels to hold this in the lathe. This bore here is machined, and I'm hoping that it's machined true with our bearing journals there. So we'll try that. We'll put an indicator on it, make sure it's running true. If that's not the case, then we'll back up and we'll set it up so that it is running nice and true. So expanding mandrel for this guy right here. For this one, we're going to go ahead and machine a mandrel for this. So this is a 5/8 bore. And what I'm planning on doing, I've got this piece of stock right here. This is something that we had made in the CNC lathe a while back, just a drop piece. So we'll just modify this. We can chuck it in our Precision Matthews over here, and we'll just turn this down so that the pulley will fit on there. We'll turn and thread this in to fit a one of these 1/2-13 flange nuts. So that'll go on the mandrel like that, and we'll just have a nut and a washer there to hold it on, and then we can get in there and turn that. Matter of fact, I'll probably have it on there in this configuration like that. And all we got to do is just face it clean on one side, turn the OD, and then we'll have to set our compound on this same angle. So we'll stick an indicator on there and make sure that the compound is lined up even with that angle, and then we'll trim that inside to clean that up. All right, do the same exact thing with this one right there. All right. So we'll go ahead and get started on it. I think I'm going to start with this guy first. We'll go to the lathe with this and start making our mandrel. Okay, we'll start with our mandrel. I'm just going to use our 3-jaw here. I've already done a predetermined length that I want. Coincidentally, this is the exact length that I want to turn for our pulley and our flange nut and washer, which is 3 5/8. I also need just a little bit of extra there, because what I'm going to do is reduce this diameter. I'll show you what I'm talking about in a bit here, but I just want to reduce that diameter, so we'll just give that a little gap there. Get it tightened up and we'll start turning it. First thing I want to do is go ahead and touch up that center. Now that existing center isn't going to be running absolutely true, but I can just visually look at it and tell that it's probably within a few thou. So we're just going to go ahead and touch it with a center drill here just to clean it up. I'm going to let it dwell in there. That should help clean it up nice and straight. All right, we're going to use our live center for this. And I'm using my, this is my Written Industries center that I had them rebuild. I love these tips right here. It's got the extended tip that helps give clearance for these turning tools. And you can see what I'm talking about right here with the clearance that this live center gives you with your turning tools. Touch off on our tallest diameter here and just start roughing it down. So we're going to take this down to 5/8. I believe this is going to be some 4140. Sounds like it is, and it's making a chip like it is. So we've got some good quality steel here that we're using to make this mandrel. gonna go right up to that. That'll set me a Z0 right there. And just keep on roughing it down. All right, I'm going to go ahead and get a measurement on what this bore is. I know it's slightly over 5/8, but let's use our telescope gauge and our 0 to 1 micrometer and see what it's actually measuring. And 627. Do it again. I usually measure 2 or 3 times and try to get the average there. 627.5. Okay, let's check this other side. Let's see how straight it is. Looks like about 627.5. All right, so we'll just shoot for our mandrel size to be maybe 626. That should give it about 1 thou to 1.5 thou clearance. We want it to just easily slide on without being too loose and floppy on there. So I think 626 for our mandrel should be a good size to shoot for. Go ahead and see where we're at. I think I still got about a couple 100 thou to turn it down. Yep. No, I'm sorry. Got about 100. So about 150 is what we got to come off there. We'll go ahead and take another hundo, get that rough down, and then we'll take our finish pass. I always love getting to be able to turn and machine 4140. It's a little tougher material, you know, it's a little tougher on tools because of its hardness, but it's a good solid material that keeps its shape, and it puts off a good chip, so you get good chip control, and it usually leaves a good finish too. We're only spending 600 RPM on this right here, 620. And we're, you know, get down to our small diameters. You can see it's still leaving a pretty good finish on there. So for our finish turn, we'll probably go ahead and kick it up a notch to 900 be the next speed. All right, so we got about 20 thou to take off of this to bring it to size. So I'll take one pass. All I'm gonna do is split it in half. One pass, then we'll mic it, and then take the second pass, and that'll bring it down to size. All right. Changed my mind. That's 1200 RPM. And you can see that the finish looks a little more dull because we're only taking I dialed in 15 thousandths. I think that's going to give us about 10 to come off of the next pass there. I'm not looking for a super smooth finish, so I left it at a high feed rate there, just to kind of speed this process up. So let's mic it and see where we're at. Doesn't feel fuzzy or anything. All right, so we have 10 minus 1, so we got 9 thousandths come off of there. It's looking good, nice and straight. Okay, so that's measuring 635 on the micrometer there, so that's 9 thou. We'll just go ahead and dial in 9 and see if that gives us what we want. And we go into our 0. Added about 5 thousandths to that and just manually face it back. Clean that face up. Now I said I want to turn this back a little bit, and that's what we're going to do now. And the reason why I want to do that, I'm going to go ahead and slow that back down, is, let me get the pulley over here and show you. So we want to go on there with our pulley like that. I don't want this larger diameter pushing necessarily out here, because you can see the diameter down at the bottom is much smaller. We'll just measure it with some calipers. It's right around 1 inch, 150 thousandths. So that's what I would like that diameter to be, just to prevent any kind of pushing out here along the the side of the groove, the pulley, the flange area. I don't want to push on that. We want to push on the solid material in the center of the pulley there. So we want that 1 inch 150, and that is at 380, so we can take, like, 2 passes across there, and that's going to be good. Let me get you in there so you can see it. Doesn't need much. Oh, well, I got to dial it in. Let me see. All I did was set a 0 there. All right, so just need to go in a little bit. Doesn't really need much. That's good enough there. All right, let's take another 120. And I think that'll put us right at the 1 inch 50, I think. All right, so let's see. Yeah, see, that's going to be good enough right about there. We will chamfer it, but next thing we need to do is go ahead and turn the end here for our 1/2-13 nut. I'd like to set a Z distance. I'm going to come back to the shoulder and just touch it lightly. We're going to 0 that. I'm going to back it off 2 7/16. That'll be our stop point. Right about there. It's nothing critical. That's going to allow the thread and the undercut to go underneath where the pulley is, so the thread will go all the way up to the edge of the pulley there. All right. We've got a 0. And so we know we're at 5/8, so we've got another 100 to come off there, 125. Just go ahead and take 100. There we go, that's good enough. And let's go ahead and speed this back up, and we're going to slow our feed rate down. See where we're at on our size. Yep, we got 23 plus 5. So same thing, we'll just take 15 thousandths right there. I always finish my threads about 5 thousandths under the nominal size, so we're shooting for 0.495. Nothing critical, just touch that shoulder. Take another measurement, and it says we got 8, so let's take 13. There we go. Just clean that up. Okay, I think our diameter should be good. Let me go ahead and measure it, make sure. We should be about 495, and we are 0.495 on the mic there. This would be for our chamfers. A little bit high, just because we're usually on this tool right here, I'm using this, but because it's at a negative rake, this side's a little bit higher. So just drop that down. Just want to break these corners so you don't have a burr. Can we get up to this one? I think we can. Yep, there we go. This is my Walter MX22. This is used for grooving and threading. I just thought I would show this to you. I've got all three different inserts here. So we have our threading insert. I had a grooving insert on here. I've got a few different sizes, and they make these in a lot of different sizes. So that one's 1/16 groove size. I've got them up to 1/8. And then you have different radius inserts there as well. This one's 1/8 wide. This is the one that we're going to go on there with now because I just want to create a little thread relief and undercut. But these are great inserts because you actually have 4. It is an on-edge style insert, but the way they got these pockets made is that it's very rigid once it goes in there. You have a lot of contact around this insert to hold it in place. So just wanted to show that to you. So we'll use our round grooving insert right here to cut a thread relief, and then we'll take that insert out, and then we'll put our threading insert in there to cut our 13 pitch thread. Okay, we got this slowed down to 380, by the way, and then we want to go a double depth. We're just going to go a little over 100 thousandths deep on this undercut. Now this is not necessary right here. You don't have to have this, but this is the way that I always like machining my threads on the lathe. It makes it look nicer, prettier. I like the radius in there, and then it does create a stronger joint there. It's not needed for a job like this, but in most cases you'd always want a radius or some kind of slight radius in the corner. I'm just coming right up to that shoulder. I can see the line. I don't know if you can, but I can see the face that I already faced, and I'm going to come up and just blend it. There it is, blended, and just back it back out. And I'm going to come back in here. I'm going to widen it out just a little bit more, and I'm going to use my compound to back it up. All right, now we're going to swap that insert out for my threading insert next. Make this a little bit easier for you guys to see. We'll just put some of this blue Sharpie ink on there. I don't necessarily need this when I'm threading, but it definitely helps in the video. It helps with the visual so you can see the thread. Just give that a second to dry. All right, we've got the machine set at to cut 13 threads per inch. And we're going to go ahead, and I've got a compound. I've got my cross slide set to a 0, and I'm using a compound slide set at 29.5 degrees. This is my preferred way of threading, compound in feed. All right, so we're just touching it there. I'm going to set a 0 on this collar here. I forgot you got to use an Allen wrench to loosen this collar. I'll be right back. All right, we got our collar set to a 0. I'm going to dial in 2 thou, and let's go ahead, and I engaged on the number 3. Bring it back to a 0. All right, so the next thing we want to do, if there's one thing that I try to teach everybody that's watching these videos, is that when you're going to cut a thread, always verify it. Make sure you have a screw pitch gauge like this right here. Have you a standard and a metric pitch gauge, and line it up to verify that you have your machine set up to cut the proper thread there. All right, so that looks good. It's lined up on the 13 leaf, so we're good to go. So when you if you're going to use compound in feed like I'm going to do, 30 degree. So this is a really simple formula to figure out approximately the depth that you take. You're still going to have to do your measuring and fitting and that kind of stuff, but this gets you close. Simple. 0.75, which is 3/4, obviously, divided by your pitch. So in our case, 13. That's going to be your approximate compound in feed set to 30 degrees. So we'll just round that up to 58 thousandths, all right? If you're cutting a 12 pitch, you'd go 0.75 divided by 12. equals 62. That was the most common thread I used to always cut when I was doing hydraulic, was a 12 pitch. So I just knew that in my head all the time, and I could go in approximately 62 to 65 thou, and it would land where I needed to every time. So anyway, once again, 0.75 divided by 13 equals 0.057. So that's going to be our approximate end feed on our compound. Now, since this is just a mandrel we're using to hold this, I'm not concerned about being on a proper pitch diameter. I always just take whatever hardware I'm going to be using and make sure that it screws on there. I don't want a super loose, sloppy fit, but I know we should get it really, really close by just feel, okay? If I can get it started, there we go. See, it's trying to go on there. We went 58 thousandths, just like I calculated, exactly. And you can see that it's a little snug. I have not filed the top, so there's still probably a little burr right on the top there. But this is telling me that we're going to have to take at least a couple more thou off the thread there using our compound end feed. So let's just go ahead and do that. All right, as you guys just saw there, I took 2 thousandths on the dial, so we're at a total of 60 thou end feed for that 13 pitch, and you can see this flange nut fits on there just like it's supposed to. So all we need to do is just a little bit of file in there. I really don't even feel a burr, but we'll just clean up that thread, remove the burr there, and this will be done. I might have to do a little polishing on this because we haven't checked that yet, but that's what we'll do now. Let's go ahead and see if the pulley will even slide on there where it's at. Feels like there's a little rolled over edge right on the end of that. I might have to do some deburring there because it feels like it's just trying to, just making sure that I'm going on there straight with it. It's trying to. I was just making a dumb mistake, overlooked on my part. There's a set screw there and it was sticking down through that keyway. So that's what we were actually hitting. But I went ahead and deburred it, and that's when I realized there's a set screw in there. So let's see if that's what it was. Perfect, just like that, see? Good fit. We don't even need to file it or anything. I am going to clean it up, but I'm curious, since we're already right here, I'm going to use a washer and this flange nut. You can see what kind of fit we got on that. It's very close. And let me find a wrench. And let's go ahead and spin it. I want to see if this thing is going to be running straight. Yeah, it looks pretty good. It's not perfect, but I think that's going to allow us to do what we're wanting to do. Well, of course, we'll put our center back up here to support this too. So I think that's going to work. I'm going to go ahead and just clean up that, get rid of the burrs, and then we'll put it back on there, and then we'll start with getting our pulley turned, get that weld turned off there. All right, we got our threads polished there. So we'll go ahead and go back on. I like that fit. That turned out good. Now this time we'll go ahead and put our center in there to support that. Best thing to do, if you can, whenever you're tightening up a nut like that on a mandrel. Not going to need a lot. That should be plenty right there. Still looking good. Yep. All right, so we're ready to move on and get this weld turned off of there. Alrighty, let's go ahead and see if we can get this turned. We'll start with the OD and then we'll face this side there as well. I do have a aluminum grade insert in there and hopefully that'll work pretty good. This is what I was gonna use on the beauty rings and the pacemaker that I ended up, doing the CNC machining anyway. So I haven't used this yet. It should work pretty good here, hopefully. So I think what I wanna do to start is, let me see if I can come over here. I don't know if I could get in there and like touch that diameter without hitting the weld on the tool. I think we might be able to just do it. What I want to do is just kind of get an X tool position established. All right, it's just touching. I'm going to go ahead and hit X at 0 right there. Come up here and touch and see how much we got to come off. All right, we're touching there, so we got about 113 thousandths it says. Let's take 50 thou on here. I got to reset my speed or my feed, so I'll be right back. All right, here we go. That was just 50 thou right there. I'm just trying to sneak up on it. This will be 100 total. It looks like it's going to fill it in nicely. It is right there at it. I feel like this side's actually a smaller diameter than this side right there. I think that's what's happening. I did not measure it. So I think what we're gonna do, I'm just gonna bring the tool in. I'm looking down and I'm just really gonna eyeball this as well. There we go. I think that was getting pretty close, just working it by hand. Just working it by hand and then looking at it. Looks like we're getting really close. I can tell that we're touching right here. So you got some wear on this pulley, but it's, this thing is old, been around a while. I think we'll go just a touch more. Okay. I think we'll stop there. So we're already cutting this part of the pulley flange. So I think we're just going to leave it right there where it's at. We can go ahead and work on the face now though and get that cleaned up. Same thing. I'm just going to come in here and just kind of work this manually by hand, not engaging any feeds right now. The face is not perfectly true. So really we just want to try to clean it up best we can. Something like that right there, but we can also go in there with some Scotch-Brite and polish all that together. It's just coming in to where the weld is there. It's one of those situations, you see we're touching on half of it and not on the other half. I don't know how much it's going to take to clean it up without putting an indicator on it, but we really don't want to take any of that material off because this is all original. So we may leave it right where it's at and just kind of hit this with some of that emery and polish it together. I think that's I think it's good right where it's at. We'll go ahead and hit it with our Scotch-Brite and see what it does. Hoping that it just kind of blends everything together. Doesn't look too bad, does it? I think we can live with that. We're going to go ahead and get our compound lined up on this angle here. So I decided I'm going to use this groove right here because it is the less worn of the other three. I can tell that the one out here that we got to cut has been used quite a bit, and the one on the inside here, the smallest groove, that one's been used a lot. This one's got a little wear, but this one has the least amount of wear. So we should be able to have a good surface there to indicate on, and we'll use that to cut our weld to that same angle there. All right, so I'm gonna go ahead and just loosen up the compound and just kind of pivot around, probably around 10, 12 degrees is gonna put us pretty close, and then we'll stick a test indicator on there and then get it indicated right. So I got that loose, so I'm gonna go ahead and bump this on around. I'm just going to start on 12. I think that'll put us pretty close there, but I may be off, and we're just going to snug these just slightly. Then we'll use a saw blow hammer here on the compound and get this lined up on that angle. So for this, what we're going to use is my Starrett number 811 test indicator. Got it mounted on this little small Noga base. Maybe we'll put it there. I think we'll just try that and see if that'll work right there. All right. And I'll show you why we're going to use this guy right here. Get this in there, about in the middle. Come up with a little bit. All right, so we can just take our dial and pivot it back there. That way we can see it. All right, so now we can just use our carriage, and we'll just run it up into a 0. And now we can use our compound just like that. So you can see how I'm off quite a bit. So high in the back and then low on the outer. So now we just need to adjust our compound angle. All right, we got a little soft blow hammer here that we can use. May have these actually a little bit too tight. Let me go ahead and loosen those up again. Just gonna keep working it like this. Bring that in. Just keep working it. Getting closer. Where are we at on our degrees there? We're 13, so we've moved it 1 degree. I think I'm going to go ahead and try 15. I think I'm going to go ahead and bump it. Well, let's go ahead and bump it around another degree. We're going to go to, yeah, you can see we're much closer right there. So that up and down you see with the needle on the indicator, that's the wear. I think we're getting really close there. Just going to go a little at a time. Still a little bit high. That's that war area that I keep stopping in right out there. So it's still about 2 or 3 thou. Very close. I think that's within a thousandth right there. I'm going to see if I can get it closer though, because we should be able to. So we can go back to our fine bumping like that. Pretty darn close. We're going to go another bump. Let's call that 0, half a thou. I think it's about a half a thousandths off. And I believe that's putting us within a half a thousandths right there. I think we're pretty good right there where we're at, and that's showing approximately 14 degrees, maybe just over 14 degrees. So I think that's going to be about a 30 degree included angle right there on that V groove. So we'll go ahead and lock those back down, but that worked out pretty good. Love using my Starrett number 811 test indicator. All right, I've been getting my tool set up. I decided I'm going to go ahead and run this guy right here. That should be a VNMG style insert. And I've got it mounted upside down in the tool block right here. We've got it sitting on a couple of these 1/2-inch magnetic blocks from Fireball to kind of get it up as high as we can. And now I've actually got it adjusted to where it's matching the center line there using our live center. So that should reach into this groove and provide plenty of clearance here on this side of the tool. So as we come in here, it's not going to rub that side. And then keep in mind, so we're going to be running this in reverse now that the tip of the tool is upside down. Okay, let's get this guy cut. I'm going to run it in reverse. Just going to work this by hand, left hand on the carriage, right hand on the compound. Just cut a little at a time. I know that insert is not really the right one for aluminum, but it was what was in there, and it's going to get the job done. Let's see what it's looking like right there. So one of the things that I already know we're going to deal with is the fact that this groove has quite a bit of wear in it. Okay, it's not a perfect angle like the one that we indicated right there. That one's not perfect either, but it's closer than this one. We're not going to be able to go in there and clean up every single bit of that weld in there because it's kind of dished out. So we may just have to do a little bit of hand polishing on that just to kind of blend in where those weld beads kind of flow into the actual pulley, just to kind of get it close. All right. I've been taking 2/1000ths of pass, and you can see that our cut area is getting very, very close to where our buildup is. I'm going to go ahead and take another 2 thou. I told you I didn't want to try to clean this whole thing up. You can see it's not running perfectly true, but it's so close. It's hard to determine how much it would take to actually clean the rest of this up. I really just wanted to get through the weld there so that this is all blended and there's no kind of sharpness in there for the belt to kind of rub on. So let's just try another couple thou and see if that'll help clean that up.
2/1000.
we got it that time. I'm gonna back off just a touch. And I think our weld, that's our weld area right there. So it cleaned that up nicely. I only see there's a couple little pinholes in there, not bad. And you can see right there, right up in there, well, it's hard to tell, but there's a little bit of paint left right up in there. We pretty well got that cleaned up. I think that is, there's nothing wrong with that right there. Our pulley is looking really good. I'm real happy with the results there. Last thing I need to do, I'm just going to use my file here to file this corner off. It's got a little bit of a sharp edge. Just going to file it, and we're going to polish that with that Scotch-Brite again. Just going to use the smooth side and just round that corner a little bit. That looks pretty good. That feels nice. Let's soften that up good. And we'll take our Scotch-Brite. Got our Scotch-Brite pad. This one's made for aluminum too. I'm gonna fold it over. Just go in there with it and polish that guy out. Make the OD look good. We'll go ahead and hit this face again one more time while we're on it. And I think that's gonna finish that guy up. It looks pretty good. Standing here looking at it like this, if you didn't know that that was welded, you really wouldn't, you couldn't tell. Now looking from the outside, we still got a little bit out there on this little outside area, but again, I just didn't want to clean all that factory face off of there, so it's fine just the way it is. And you have one little shallow right where the bead starts on both sides. That's really all the only way you can tell. We're just nitpicking that. It's good enough. It's really good. Look at the inside of it. The inside where the belt runs looks better than the top and the outside. So I'm going to consider this guy done. What you guys think? Is that good enough for you? Satisfactory? Good enough? I think it's going to get the job done, and it shouldn't be tearing up any belts. All right, first pulley done, so we'll go ahead and move on to our second pulley now. All right, so we're going to move on to our second pulley here, and as I mentioned, my plan is to run the center bore of the pulley on an expanding mandrel. So this is the mandrel that we're going to be using here, just an expanding sleeve. So we can go ahead and actually slide it up on there a little bit if we want to. Just get it to where it's closely fitting. And once you get it where I want it, I want to make sure that the expanding mandrel is not sticking out past the pulley there. So I'm pushing it down. All right, and we'll just take this block, just give it a couple bumps like that, and it should be seated on there good enough for what we're doing. We're not taking any heavy cuts on this part right there, so those couple of bumps that I did on that block is more than enough to hold this on this expanding mandrel. So we'll chuck it here in the 3-jaw, run our live center on it, and we'll see how true it runs. Oh, that's looking nice. I think that's running better than the first pulley that we did. I think it looks great. So we'll just roll with that. It's going to be pretty good. So I believe that this groove that we got to work on, I can actually feel the wear with my finger in there. So we're not really going to have a nice straight cut through there. I don't think. I think if we clean that up, we're going to be making this so thin out here that it won't be good. So we're really just going to try to do what we can, just eyeball it and just kind of go from there. All right, let's get rolling on this. We're going to do the same thing we did on the first one. I'm really just going to kind of just kind of judge by sight on this. I'm just looking down from the top here. Just going until everything's kind of blended together. All right, don't know if we're going to get the OD of it fully cleaned up. We might, but I think there's going to be a little low spot right there. Still got a little bit more we can go. Okay, we've got it cleaned up on the OD. I'm going to move over to the face. Let's get this cleaned up, and then we'll work on our inside. I think what I'll do is put my little carriage indicator down here just to kind of see what my movements are. I'm just going to feed this in. Should clean up pretty good. Right there. I'm going to come in here with a tool, and I'm watching my indicator. I want to see where it touches. So, all right, so that's 5 thousandths. Back off. And we'll go back into that 5 thou mark, which is 65 on the indicator. And go ahead and face it. Let's see if that cleans it up. Not quite. It's right there though. I think we could stand to maybe take a couple more and see if we can get all that evenly. Tell you what, let's go up in speed. Go up to 900. Go another 2 thou and see what happens. Yeah, it's cleaning it up. All right, yeah, that's got it there. Now there is you can see a few little pinholes in there, little shallow pinholes. It doesn't go all the way through. Keep in mind, this was cast aluminum that was being welded up, so not the best stuff to work with. But I think that's good enough for what we're doing there. So we got our OD, we got our face. We'll go ahead and move over to the inside. Now what I'd like to do is go ahead and set up our indicator again. I've got this set right where we indicated on the previous pulley. So we'll go ahead and check it on one of these and see, you know, if the angle is matched up good. So the angle wasn't the exact same as the other, although they should all be the same, but there was a slight amount of variance. So I went ahead and bumped it just a little bit, and I've used these 2 grooves right here. They seem to be the cleanest of all 4 of them, and there's just a little bit of an area that's flat in there. And I've got our test indicator. You can see I'm running it in and out. We've got a spot in there that's not very wide that I've got it running within a thousandth or so. Looks like it's moving about a 1/2 thousandths, and then it gets to that wear spot and the needle just drops off like that, see? So you just got that one little area down in there where the belt really hasn't run. So we've got it lined up on that. I feel it's pretty good there. So we're just gonna go ahead and lock that back down. It's only moved, I don't know, maybe about a 1/2 degree. So I just wanted to get lined up on the actual groove that was already machined in the pulley and just make sure that it matches well there. All right, so this is the tool that we were using to cut that first pulley, and it's not going to work on this one just because the diameters are larger here on the left side. You can see that it would actually hit the tool there. So I pull that one out. And we have this Walter grooving tool right here. I think we'll just set that up, and we have just enough reach to where if that insert's touching that smaller bore down in there, I'm sorry, the small diameter, it's not gonna touch, it's not gonna hit the OD of the pulley there. So we have just enough extension there that we can get in there and cut it with that. So we'll just use this guy here. All right, let's start cutting this. I've got my compound set to where when I go all the way in like that, it actually will run out of feed just before it gets to that bottom. So that's kind of a natural stop that I can go to. So we'll just use our Z movements here. And let's fire it up. I'm just working the compound. Getting into that where we're touching down at the bottom and out here. So now we're into that wear zone. It's just a matter of how much I want to take off to clean it up. So this is where I'm really just taking like 2/1000ths a pass. We're moving that way about 2/1000ths and just taking a cut. It looks like it's taking a lot, but you know, you're talking 2/1000ths of an inch. So not really a lot of material there. And I'm just gonna do that a little bit and keep looking at it. It's just about cleaned it up. Well, I think I got this guy finished up there. I went ahead and took another 5/1000ths off the OD, and that did clean up that weld there. And I touched the face. I took 2/1000ths off that face, and it actually cleaned it off there. You only see just a few of the little pinholes in there where it was, you know, trying to fuse it with the cast aluminum. The inside's got a couple little hollows down in there, very minor, but I tried to clean it up as best I can without taking any extra. So that last pass where we took another 2/1000, it cleaned it up all the way to the bottom. I just left it at that, and I think it's going to be good enough. I still need to file that sharp edge off of it, and we're going to hit it with our Scotch-Brite, but I'm happy with the results there. I think it looks good. Nothing left to do but to get it out of the machine and off the mandrel. Try it on this guy right here, that end, since that's the messed up end. Let's see if this works. There we go. Easy as that. All right, guys, well, that is going to wrap up our repair on our 2 South Bend pulleys here. I'm happy with the results. I'm happy with the way it came out. Is it 100%? I won't call it 100%, but I think we're really, really close. You know, doing these kind of castings like this, or repairing these castings, is always a little bit tricky, and you know, getting the welds perfect in there. But I didn't want to take a bunch off of this factory face. I just wanted to kind of leave it original, you know. That's why I didn't clean that all the way up. But I think it's going to be just fine. And once these guys are installed, I don't even think you're going to really see that there. But it did turn out good. The inside cleaned up really well. There is a couple little tiny pinholes in there where the weld is. And then the same as for this one right here. You can see you got a few pinholes there. And then there's one little tiny hollow up inside there that I wish could have cleaned up. But that means that we would have had to weld it back up and do it again. I don't see anything wrong with this. I think it's going to run fine just the way it is. It should not mess up a belt, and I'm happy with it. So we're just gonna let it run just like it is. Hopefully Chris will like this, and he can go ahead and get these guys put back on his restoration project and get this guy completed. I think this was one of the things that he was kind of waiting on, this right here, to get them back. So we showed how to make a mandrel like this guy right here that we use to hold this one. This is an excellent technique for you guys out here learning, watching these videos, and you're trying to pick up on some tips. You know, if you have some scrap stock around, that's great for doing stuff like this. And it's great for jobs like this where you don't necessarily want to try to put this in a 3-jaw chuck or a 4-jaw chuck and risk distorting this little thin area out here. If you've got a nice board that you can work off of, that is the perfect way to hold something when you're doing some OD work, as long as it's going to allow your outside, you know, if it's turned true, everything's machine true together. So that's a good technique. So keep that in your toolbox for future jobs right there. And then our expanding mandrel, these always work out really well whenever when I have a job that's suited for stuff like this. I'd highly recommend trying to get some of these and put them in your box. They're still out there. You can get them. You can get some imported ones, you know, for not that much money. All of mine were passed down to me from dad and granddad. So this one right here, I was just looking at. This is the first time that I've ever looked at the name on here. I just never paid it any attention, but it's really, really hard to see. But I can make out that this is a KO Lee. It says KO Lee Company. It has a logo right there in the center that says Knockout. And then over here, I believe it says Aberdeen, South Dakota. I had no idea that KO Lee was in the South Dakota, was in the state of South Dakota. I've never really heard of anything being made up there. Not saying that there's not, but that just kind of surprised me to see South Dakota there on the tool. So this is an oldie and a goodie, and you can still get them. And I've got these up to, I believe it's 3-inch or 3.5-inch. Handy for a lot of things, especially jobs like this right here. So if you can, put some of these in your toolbox and have them ready for some of these jobs. So that's it, guys. We're gonna get these boxed up, get them sent up there to Chris so he can finish up his restoration. And I hope you guys enjoyed the project, enjoyed following along, and I hope to see you back here again on the next project. All right, see you then.